A long time ago, when the Egyptians were trying to count things, they found that sometimes they needed to count things that were not just 1, 2, 3, 4, or 5, but they had fractional things. And so the Egyptians created a new type of number called a fraction. Later, the Mayans were finding out that when they were counting things, 1, 2, 3, 4, it was useful to have a placeholder for 0 representing nothing. And so the Mayans created a new type of number called 0. Several times throughout civilizations, we have found a need for a new type of number, and those new type of numbers help us solve different types of problems that we couldn't solve with the old types of problems. One of those such numbers is complex numbers. It came out of the need to solve the problem x squared equals -1. Because we could usually think about getting rid of squared by taking the square root of both sides, which would give us x equals the square root of -1. The problem is we cannot take the square root of -1. There's no number where you square it, it becomes a negative number. And so we have to create a new type of number. And they call this new type of number an imaginary number. Now, don't be fooled by the name imaginary number. It doesn't mean it's just pretend. Actually, these numbers really do exist. They've just been called imaginary numbers because we use the letter I to represent them. But don't think that means they don't exist. They really do exist, and they help us solve many useful applications. So the idea behind an imaginary number is that the square root of -1 is going to be defined as a new number. We're going to call that new number I. Just like the Egyptians made fractions, just like the Mayans made 0, we are going to make I, the imaginary number, be the square root of -1. And so now that allows us to solve problems like the square root of -9, because I can rewrite this as two parts. We've got the square root of the 9 and the square root of the negative. We'll call that -1. The square root of -9 is 3 because 3 times itself is 9. And the square root of -1, we have said, is I. So the square root of -9 is 3i. So this kind of gives birth to the new types of numbers that we're going to be talking about today called complex numbers. A complex number is a number that's written as some number plus another number times the imaginary number I. We're going to say the first part of this is the real part, the A. The second part is the imaginary part. And together, a real number plus or minus an imaginary number creates what we call our complex numbers. Now, what's nice about these new complex numbers is they still work very much like every other number we have seen before. So we can do algebra with these complex numbers. And it's going to work very similar to how algebra works with normal numbers. And this falls with polynomials because it behaves a lot like polynomials do, because the I acts just like a variable. So for example, if we want to add two complex numbers, all we have to do is combine like terms. For example, if I've got the complex number 2 minus 4i, and I want to add to it the complex number 3 plus 7i, I can combine the real parts, 2 plus 3 is 5, and the complex parts, -4 plus 7 is +3 of these imaginary pieces. So we have 5 plus 3i is the complex sum of these two complex numbers. Subtracting is very similar. The one thing we need to remember is that we have to distribute the negative first. Here's what I mean by that. Let's say we've got 2 minus 4i, and this time we're going to subtract 5 minus 3i. Well, what I'll do is I'll take this negative and it has to go onto both parts. So the problem now becomes 2 minus 4i, and now we've got a negative 5, and a negative negative makes positive 3i. It has to distribute all the way through, and then it becomes like an addition problem where we combine like terms. The real parts are 2 minus 5, which is negative 3. The imaginary parts, negative 4i plus 3i is a negative 1i. We don't have to write the 1, and so we have negative 3 minus I. So that's adding and subtracting. Let's talk about multiplying. The main thing that we think about with multiplying is that I multiplied by I, just like x times x is x squared, I times I is I squared. But remember, I is the square root of negative 1, so that's like saying the square root of negative 1 squared, which means square and square root undo each other, leaving just negative 1. In other words, anytime we see I squared, we're going to convert it to the real number, negative 1. Let's see what that looks like. Let's do a couple of these. Let's say we've got 4 i's, and we want to multiply them by 3 i's. Well, 4 times 3 is 12, and I times I is I squared. But that I squared becomes a negative, and so it actually simplifies to negative 12. And no more i's are needed because it got absorbed into that negative. Let's do one more. Let's do negative 2i times 7i. Well, negative 2 times 7 is negative 14, and I times I is I squared. But the I squared is going to become negative 1, so we've got negative negative 14, and two negatives make it a positive 14. So I squared changes the sign and makes it positive. We can extend this idea of multiplying to distributing and solving problems like 3i times 7 minus 6i. When I distribute, 3i times 7 is 21i, and 3i times negative 6i is negative 18i squared. But the I squared is going to make that 18 positive. So we've got a positive 18 and a positive 21i for our final answer. We usually put the real part at the beginning. I could have said 21i plus 18, and technically that's correct, but we usually like to see the real part first. So it's better to write 18 plus 21i. And if we can distribute with complex numbers, we can also multiply binomials together, which really is just a lot of distributing. Let's say we've got 6 minus 3i, and we want to multiply by 2 minus 4i. Well, we know from algebra that we're going to take this first number 6 and distribute it onto both parts. 6 times 2 is 12. 6 times negative 4i is negative 24i. Negative 3i times 2 is negative 6i, and negative 3i times negative 4i is positive 12i squared. Again, the I squared is going to come in as a negative, so we've really got 12 minus 24i minus 6i minus 12. And then when I combine like terms, the real numbers, 12 minus 12, here go to 0. So we're just left with negative 24i and negative 6i, which is negative 30i. Very closely related to multiplying binomials is squaring a binomial. When we square a number, we know that means we're going to multiply by itself. So if I have 3 plus 5i, and I want to square it, I know that means I'm actually taking 3 plus 5i times itself, 3 plus 5i. And then it becomes a problem just like the one we saw previously. We'll do 3 times 3 to get 9, 3 times 5i to get 15i, 5i times 3 to get 15i, and 5i times 5i is 25i squared. Again, the I squared is going to make the whole thing change its sign. It's going to be a negative. So we've actually got 9 plus 15i plus 15i minus 25. And so when I combine like terms, the real parts, 9 minus 25 is negative 16. 15i plus 15i is positive 30i. Now I've got my solution to squaring my complex number. The only special thing about I is it has this property that I is the square root of negative 1. If I keep that in mind, I squared then becomes negative 1. Everything else simplifies like all other polynomial algebra simplified. It's your turn to practice some of these. Good luck on the assignment.